Okay, this is a lesson on how to solve quadratic word problems. Now we're going to look at 4 problems. The first is this one. The profit, capital P, in dollars gained by selling X number of computers is modeled by this equation. Profit is equal to negative 5x squared plus 1000x plus 5000. Now the question is, how many computers do we have to sell in order to get a profit of $55,000? So we've been given the equation in this case. So we don't have to do anything to put the equation together. And we've also been given the profit, P, of $55,000. So we're going to substitute 55,000 for P in the equation, and then we're going to solve for X. That's the number of computers. Now to do this, we need to subtract 55,000 from both sides of the equation, because in every case of solving, we need to start out with the standard form of ax squared plus bx plus c is equal to 0. So we need to get rid of that 55,000 on the left side of the equation. To do that, we subtract that from both sides of the equation, and that gives us negative 5x squared plus 1000x minus 50,000. And yes, that is a typo. That should be negative 5x squared. Now we identify A, B, and C, and in this case, I'm going to use the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And yes, you're going to need to memorize the quadratic formula. So I do my substitutions, and then I simplify. When I do, I get negative 1,000 plus or minus the square root of 0, all divided by negative 10. Now the square root of 0 is 0, so that's really negative 1,000 divided by negative 10, which gives me 100. We only have one solution in this case. X is equal to 100. And so that means we need to sell 100 computers in order to obtain a profit of $55,000. Now when you get an answer like this to a word problem, it is a good idea to write out the answer the way it's written out here. 100 computers must be sold in order to obtain a profit of $55,000. Pause now and copy this entire example. Here's our next word problem. The product of 2 consecutive even integers is 840. Find the numbers. Now you know that integers are numbers. They're counting numbers. And this is saying that we have 2 even integers. They are consecutive, and that their their product, when we multiply them together, is equal to 840. And so let's define the first integer, even integer, to be x. Now, we know that the next integer right after that would be an odd integer. So the next even integer is x plus 2, or 2 places away from x, our even integer. Now we're going to write our equation. The problem told us that the product of those 2 even integers is 840. That means we multiply them together. So we have x times x plus 2 is equal to 840. When we go ahead and multiply that out, we get x squared plus 2x is equal to 840. Now we already have the variables on one side and the constant on the other. That makes it very convenient for us to use completing the square to solve this problem, and so I'm going to do that. We are going to make a space for where we're going to add a constant to both sides of the equation. Then we're going to identify b, which is 2. We're going to divide that by 2 and square that result. Now 2 divided by 2 is 1, and 1 squared is 1. So we end up adding 1 to both sides of the equation. Now we're going to factor the left side of the equation. We know that because we went through the process of identifying b, dividing it by 2, squaring it, and adding it, that we created a perfect square on the left side of the equation, and we can factor that to be x plus 1 squared. And on the right side of the equation, we add 1 to 840, and we end up with 841. Now we're going to take the square root of both sides of the equation. Don't forget that when you take the square root of the constant, you need to account for the positive case and the negative case. So you need that plus and minus there. Now we're going to subtract 1 from both sides of the equation. Before we do that though, we're going to simplify the square root of 841, and it turns out that that is a perfect square of 29. So now we're going to subtract 1 from both sides of the equation. We have 1 plus 29 and 1 minus 29. So that means we have 2 x-intercepts, or 2 answers. One is x is equal to 28, and the other is x is equal to negative 30. All right, let's go on. But before we go on, let's talk about how you can get 28 and negative 30 and what that means. It means that the numbers can be 28 and 30, or they can be negative 28 and 30. Now we can go over that more in class, but if you're confused about that, why don't you try substituting 28 and 30 into the equation and negative 28 and negative 30 in, and seeing what happens, and let's talk about it in class. Pause now and copy down this example. Now, here's your third word problem. One side of a rectangle is 3 feet shorter than twice the other side. Find the sides if the area is 209 square feet. Now, when you're talking about rectangles, triangles, that kind of geometric figure, it's always a good idea to start with a figure, to draw a picture, and then label your sides. And so it's said that it's 3 feet shorter, that means 3 feet less, than twice the other side. So we represent that as 2x, that's twice the other side, minus 3. And then we label the other side as x. Now we know that the formula for area is equal to length times width. Now we're going to use that then to write our equation. And so we're going to multiply x times 2x minus 3 and make that equal to 209. And that gives us 2x squared minus 3x is equal to 209. Now we could use completing the square here, but I want to use another method, and so that you can see other methods in use, and we can cover all of our bases. And so I'm going to factor this. Now remember, when I factor something that has an a value that is not 1, that I have to start that process by multiplying a times c, getting that number, rewriting my quadratic into a temporary quadratic, and then factoring that. Now I did that here. I did not show all of the work. Once I find the factors for my temporary quadratic, then I need to stop and plug in. Okay, I found my temporary quadratic. I factored that, and now I'm going to divide both of the numerical values by my a value, which was 2. I see that neither 19 over 2 or 19 over 2 does not simplify, and so I move that 2 in front of the x and end up with 2x plus 19. However, 22 divided by 2 is negative 11. So my factors are 2x plus 19 and x minus 11. Now to solve, I need to set each one of those equal to 0 and solve. Now you'll notice that when I set 2x plus 19 equal to 0, subtract 19 from both sides, and then divide both sides by 2, I end up with a negative value. Now we're talking about length and width here. And so it's impossible to have a negative value. So this is an extraneous solution, or a solution that's not valid for this particular word problem, because it's negative and we can't have a negative length or width. However, when I set x minus 11 equal to 0 and add 11 to both sides, I see that x is equal to 11. That means that this side is 11, and this side is 2 times 11 minus 3, or 19. Again, it's a good idea to write out your answer. Pause now and copy this example. Now we have one more example. This one is a triangle problem. We have a right triangle. The length of the longer leg is 7 more inches than the shorter leg, and the length of the hypotenuse is 8 more inches than the length of the shorter leg. Okay, now when you're dealing with word problems that involve geometric figures, it really is a good idea to draw a picture and label the sides. And so I've done that here. It says that the length of the longer leg is 7 more than the length of the shorter leg. So if I make the shorter leg x, then the longer leg is x plus 7. And then it says the hypotenuse is 8 more than the shorter leg. So that's x plus 8. Now, I'm sure that all of you remember the Pythagorean theorem. And so, if you're going to use a formula or something like the Pythagorean theorem, it's a good idea to write it down. All right, now that I've done that, then that gives me a clue of how to solve this problem. I'm going to arbitrarily select x as A, x plus 7 as B, and x plus 8 as C. Now that means I have to FOIL out x plus 7, I have to multiply that out, and x plus 8 squared. So I'm going to do that in this next step. If I multiply out x plus 7 times x plus 7, I end up with x squared plus 14x plus 49. And I had that original x squared in the first place. On this side, I have multiplied out x plus 8 times x plus 8. That gave me x squared plus 16x plus 64. Now I've got to combine like terms and put it in standard form. And so I'm going to subtract every term on this side, every term on the right side from the left side and the right side. When I do that, I end up with negative 2x on the left side and negative 15, or in other words, I end up with x squared minus 2x minus 15 is equal to 0. Now this thing is in standard form, and I'm just going to factor it. Well, when I look at two numbers that multiply to be negative 15 and add to be negative 2, it turns out they're 3 and negative 5. So I'm going to use those to write my factors. Going to set each factor equal to 0 and solve. The first one gives me x equal negative 3. I know I can't have a negative length, so that's out. It's an extraneous solution. However, the second factor gives me x is equal to 5, which tells me the side lengths are 5, 12, and 13. Please pause now and write down this example. Also, bring any questions that you may have to class. I'll see you then.